In this episode, we look at application attacks, which are attacks against the software people use to sign in, search, buy, upload, download, message, and manage information. Applications are often built to accept requests from users, process those requests, and send back responses. That normal request and response flow is exactly what attackers try to abuse. They may send unexpected input, repeat a captured action, force an application to read the wrong file, pretend a request came from a trusted user, or push the application into giving more access than it should. The important part is not memorizing scary names. You want to understand what the attacker is trying to make the application do. When you can picture the normal flow, you can start to recognize the indicators that suggest someone is twisting that flow into something unsafe. Before we continue, a quick note. This audio course is part of our companion study series. The first book is a detailed study guide that explains the exam and helps you prepare for it with confidence. The second is a Kindle-only ebook with 1,000 flashcards you can use on your mobile device or Kindle for quick review. You can find both at Cyber.Me in the Bare Metal Study Guide series. An application request is simply a message sent to the application asking it to do something. You might ask to open your account page, search for a product, upload a profile photo, reset a password, or approve a transaction. The application receives that request, checks what you are allowed to do, handles the information you provided, and sends back a response. A safe response might be your account details, a search result, a confirmation message, or an error saying the request is not allowed. Application attacks often show up when the request contains something strange or the response reveals something that should not have happened. The attacker may not need to break into the server first. They may begin by using the application exactly where it is exposed to normal users, then send carefully shaped input to see whether the application trusts too much. Injection attacks happen when an attacker sends input that the application treats as instructions instead of plain data. A search box, login form, comment field, address field, or application programming interface can all accept input. Most of the time, that input should be handled as ordinary text. In an injection attack, the attacker tries to include special characters, logic, or commands that change how the application behaves behind the scenes. Structured query language, SQL, injection is a common example where the attacker tries to interfere with how an application talks to a database. The attacker might want to bypass login, reveal records, change data, or delete information. An indicator could be unusual input in a form, repeated errors from the database, strange search behavior, or responses that reveal too much internal detail. The core idea is that unsafe input becomes unintended instruction. You can picture injection with a basic request and response example. You send a normal request asking the application to search for a customer named Maria, and the application sends back the matching customer record. An attacker sends a request that still looks like a search, but the search field contains extra logic meant to change the database question. If the application fails to separate user input from database instructions, the response may include records the attacker never should have seen. The attacker is not just searching anymore. They are trying to make the application ask the database a different question. That is why input validation and careful handling matter at a high level. The application should know the difference between data provided by a user and instructions created by trusted application code. When that boundary fails, injection becomes possible. A buffer overflow is different because it focuses on memory. A buffer is an area of memory set aside to hold data, such as a name, file value, or network message. If an application expects a certain amount of data but receives far more than it can safely handle, that extra data may spill into nearby memory. In older or poorly protected software, that overflow can cause the application to crash, behave strangely, or even run attacker-controlled code. At the Security Plus level, you do not need to become a memory specialist. You should understand the attacker's goal. They want to send more data than the application can safely hold, and then use the result to disrupt the program or gain control. Indicators may include crashes after unusual input, repeated requests with extremely long values, unexpected restarts, or security alerts tied to memory corruption. A simple way to imagine a buffer overflow is to think about a form field that expects a short name but receives a massive string of characters. A safe application should reject that input, shorten it safely, or handle it without damaging anything. A vulnerable application may try to place all of that input into a space that was never large enough. The response might be an error, a crash, or behavior that seems unrelated to the original request. Attackers may test many variations because successful exploitation can depend on exact software behavior. From a defensive point of view, the pattern matters. Normal users do not usually send unusually long values into small fields over and over. When you see repeated oversized input, crashes linked to specific requests, or strange behavior after malformed data, you may be seeing signs of overflow testing or exploitation. Replay attacks involve capturing a valid request or transaction and sending it again. The attacker may not understand every detail of the request. They may only need a copy that the application still accepts. This can matter when a request approves a payment, unlocks access, changes a setting, or confirms an identity action. A normal application should be able to tell whether a request is fresh, unique, and still valid. If it cannot, an attacker may reuse an old request to repeat the action. Think of a door system that accepts the same access signal again and again without checking whether it is old. In application terms, indicators may include duplicate transactions, repeated session tokens, repeated authentication messages, or the same request appearing again at strange times. The attacker's goal is to reuse trust that was valid once instead of earning trust again. A replay example might involve a user submitting a request to transfer funds or update an account setting. The application processes the request and sends back a successful response. An attacker who captured that request sends the same request again, hoping the application will treat it as another valid action. If the application does not use protections such as freshness checks, unique tokens, timestamps, or proper session controls, the repeated request may succeed. The dangerous part is that the request may look legitimate because it really was legitimate at one point. That makes replay different from an obviously malformed attack. The clue is repetition in the wrong context. A valid request should not always remain valid forever. When the same sensitive action appears more than once without a normal user reason, analysts should consider whether replay may be involved. Privilege escalation happens when an attacker starts with limited access and tries to gain more powerful access. This can happen inside an application when a regular user tries to act like an administrator, access another user's data, change protected settings, or reach hidden functions. The attacker may look for weak authorization checks, predictable identifiers, misconfigured roles, or flaws in how the application decides what a user can do. Authentication proves who you are, while authorization decides what you are allowed to do. Privilege escalation often abuses authorization mistakes. A user might be signed in correctly but still should not be allowed to view another customer's account or approve their own elevated permissions. Indicators include access attempts to administrative pages, changes to roles, unusual permission errors, normal accounts performing high-risk actions, or requests that modify user identifiers to reach someone else's data. A practical request and response picture can make privilege escalation easier to recognize. You sign in as a normal user and request your own account page. The application checks your identity, confirms you are allowed to view that account, and sends back your information. An attacker signs in as a normal user too, but changes a value in the request so the application asks for another user's account or an administrative function. If the application only checks that the attacker is signed in and does not check whether the attacker is allowed to access that specific resource, the response may expose protected data. The attacker's goal is not always to steal an administrator password. Sometimes the goal is to trick the application into skipping the permission check. A strong indicator is a normal account reaching resources that do not match its role, ownership, or expected behavior. Forgery attacks involve creating or altering a request so it appears to come from a trusted source, trusted user, or trusted process. One common application example is cross-site request forgery, CSRF, where an attacker tries to cause a user's browser to send a request the user did not intend to send. The user may already be signed in to a legitimate application, so the application sees a request that appears to come from an authenticated session. The attacker's goal is to borrow the user's existing trust. The request might try to change an email address, update a password, submit a form, or perform another action. Forgery can also appear when attackers tamper with tokens, headers, forms, or messages so the application accepts a false claim. Indicators include unexpected account changes, actions a user denies taking, missing anti-forgery protections, or sensitive actions triggered from unusual paths. The key to understanding forgery is that the application may receive a request that looks normal on the surface. The problem is the intent and origin behind that request. Imagine you are signed into an application, and a malicious page quietly causes your browser to send a change request in the background. The application may see your active session and process the change unless it requires a special proof that the request really came from the legitimate application page. From the attacker's view, this is useful because they do not need your password if they can misuse your already trusted session. From a defender's view, the indicator may be a sensitive request that lacks expected validation or appears after a user visited an unrelated page. Forgery is about making the application accept a request whose trust has been faked or borrowed. Directory traversal is an attack where someone tries to reach files or directories outside the area the application is supposed to expose. Applications often serve files, images, reports, downloads, templates, or documents from approved locations. A traversal attack tries to manipulate a file path so the application moves upward or sideways into places that should be off-limits. The attacker may be looking for configuration files, password files, source code, logs, backups, or private documents. At a high level, the request asks for one thing, but the path is crafted to make the application retrieve something else. Indicators include unusual file path patterns, repeated attempts to access system locations, unexpected file download errors, or requests for files that normal users would never know existed. The attacker's goal is to use the application as a doorway into the file system. You can picture directory traversal through a download feature. A normal request asks the application to download a user guide, and the application retrieves that guide from the approved document folder. An attacker sends a request that manipulates the file name or path, trying to move away from the document folder and into a protected area. If the application does not properly control which files can be requested, it may send back sensitive content. The response might be a file, an error message that reveals the system layout, or a denial if the application is protected. Even denial messages can teach an attacker something if they reveal too much. Strong design keeps users inside approved boundaries and avoids trusting user-supplied paths. When file requests show repeated probing of hidden or sensitive locations, traversal should be considered. These attacks have different names, but they share a common pattern. The attacker sends something the application accepts, then watches how the application responds. Injection asks whether input can become instruction. Buffer overflow asks whether oversized data can break memory handling. Replay asks whether an old valid request can be used again. Privilege escalation asks whether limited access can become greater access. Forgery asks whether trust can be faked or borrowed. Directory traversal asks whether file boundaries can be crossed. In each case, the attacker is testing a boundary that the application should enforce. That boundary may separate data from commands, old requests from fresh ones, regular users from administrators, trusted requests from forged ones, or public files from protected files. When a boundary is weak, the application may do something the designer never intended. Application attack indicators help you notice when normal software behavior has been pushed into abnormal territory. Strange input, repeated failed requests, oversized values, unexpected errors, duplicate transactions, unusual permission changes, sensitive actions a user did not intend, and suspicious file path attempts all deserve attention. You do not need to see the attacker sitting at a keyboard to recognize that the application is being tested. You watch the requests, the responses, the timing, the user role, and the effect. A single error may not mean an attack, but a pattern can reveal probing, exploitation, or compromise. As you continue through Security Plus, keep returning to the same question. What was the application supposed to allow? And what did this request try to make it do instead? That question will help you make sense of injection, buffer overflow, replay, privilege escalation, forgery, traversal, and many other application risks.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.